So today we've got a Uniden 100, it's lit up, it's come on 19, and I've had to open it up because I've had to have Mr. Chippy change the usual 4 capacitors because I don't power one of these up these days without changing the 220 microfarads, the 470s. What I don't want to end up doing is on switch on killing the audio IC or on switch on killing the phase lock loop chip, which is unobtainable. I mean, they're about 17 quid, but they are unobtainable. Having said that, there is someone in Brazil who'll sell me them as long as I buy 100 at £29 each. I don't think I'll be doing that. I'm having to use our mic. The customers sent an incompatible echo mic with it. I'll better have a word with him about that, because I don't think we'll be doing that. So what I want to do is to just see how well this is working at the moment. Right, so let's go into transmit. I'll switch picture in picture on. So transmit. Oh, that's is that on low power? Because that's 50 milliwatts. That's better. It's actually doing 4 watts. And low power is doing 50 milliwatts, so that one's attending to. We will, of course, retune it, but it is where it should be. So that's a good start. Let's look at deviation. Low, 1.5 kilohertz. That one's sorting out. That's far and away too low. It's like a mouse. Good. Well, that's see how I can't do anything about it being on or off frequencies. You know, these are the reference crystal on these. Oh, that's well out. That's not good at all. Let's just show you what I'm looking at. I know I've only put the test set on 10 minutes ago, but 2778, and it should be 2779125 is not acceptable. Anyway, once it's recapping, that won't sort that out though. That's not going to be easy to overcome. So, what else do I want to do? Check it on the receive. I'm going to have to set the receive on the signal generator to the same as the transmitter, otherwise we're going to get an unfair result. So I'm going to put it to 78965. 27 7 8 965. We'll just check again on transmit. 2778963. 2778965. So we're the same, which is what we're looking at. So we'll just put the extension speaker into the test equipment. Hopefully they'll respond to being cleaned for both the squelch and the volume. are not responding very well. Right. So let's see where we are. Bearing in mind these sets are nothing like as sensitive as most others. There's our 12 point on the cyanide meter. I can give it a bit more than that. There we go, 12. Now we'll go over to the attenuator and let's see where it is. So we're at 3 and we're at 1.3. So it's 1.3 microvolts for 12 dB cyanide. Now let's just see where it is for 10. We're going to recap this and it will make a difference on these. So it's, I can change scales. It's 1. We're not quite there, it's 1.0 something, so we'll put 1 microvolt for 10 dB. And if it'll do anything like 20, it will, it's 3. Right, so we've got where we are with the set. So I need to vol plus squelch to clean, and it's 27,78963. So it's miles off. It's not had anything silly done to it, has it? Okay, so I'll pass this across to Mr. Chippy and he can change all the capacitors in it. So the next day Mr. Chippy has been doing the capacitors. So we can start by doing the tune-up. You know what, that printed circuit board just feels loose in the chassis. Yep. You got any of these screws loose, you can end up with microphony. That's where when you tap the radio, it kind of amplifies the tap, and that can happen on transmit and receive. Right, we'll power it up. We'll tread with caution, power it up at 9 volts, just in case there's an error. That's fine, drawing 150 milliamps. We'll go to 13.8 volts, drawing 190 milliamps. I'll select picture in picture and the right camera. And it's still transmitting. It's interesting, it's now doing 3.5 watts. It was doing 4 yesterday. Yeah, that's interesting. So, has it had any messing about with the VCO? I don't think it has, you know, I don't think it has. It's off frequency though. We are going to have to change the reference crystal. It's so far out. I just hate to incur more costs. Well, anyway, we'll start with the transmit tune-up, and that gives us a chance for the test set to warm up. I've only just put it on, and until that's been on half an hour, I don't want to make any final decisions. So we'll get the appropriate service manual out. And that's the realistic TRC 2000. So I just wonder what the limit spec is for the receiver, because we had 1.3 microvolts yesterday for 12 decibel cyanide. They quote it for 10 decibels, and it was 1 microvolt. And the limit spec is 1 microvolt, so the radio isn't out of spec, despite me thinking it's as deaf as a post. Frequency. .005%. I'll have to get a calculator on that. So, I think we'll check the alignment. It's a long time since I've done a Uniden. It must be 3 or 4 weeks since I did that base station of horrors, which turned out alright. I can't remember whether this is a floating chassis or a negative earth chassis, so let's just check. It's a negative earth chassis, so we can just put the prod somewhere handy. We need to look for test point 1, which is resistor 52, and resistor 52, let's try and put that there, is there. So we go to channel 40, and they want 3.5 volts on transmit. So 3.8, it does need to be altered a little bit. So L17. I don't think this is a messed with set, it's a tired set, but it's not a messed with set. The fact we've changed the capacitors can also affect. I'm going to have to put a crocodile clip on this because I'm going to end up having to have quite a few hands. I could do with a few extra hands when playing the church organ as well. So going to transmit. Now the wax is cooled down. .52. So just close that back up. I'll just check that once again. 3.53, that's fine. And then we go to channel 20 on these sets. And we go on to a different test point. So we need test point 3 and we need the oscilloscope instead. I said before, I use this portable oscilloscope rather than just the bench oscilloscopes. The 2 bench oscilloscopes is set for what we do with them, so we'll bring a third one into operation because it's otherwise we're faffing around with the controls all day. So test point 3. I think is there. Resistor 6. It's that one. Resistor 6. Let's pull that forwards a fraction. So what we're looking for here, so we're on channel 20, we're on receive, we're adjusting L18 for maximum. Okay, so we've done that. Goodbye oscilloscope, that's that. I think we go back to L18 later on in the procedure. They do receive first. I'm not happy with that. We do transmit first. So they want you to do L15 and 16 on an oscilloscope for maximum. Because the set's already transmitting, we don't really need to do that. We can see it on the power meter. So they're doing this, you know, if you're setting it up from new, or if it was really, really out of alignment, you've got no transmit, that you'd be starting on those early stages with the oscilloscope. But we just don't need to do it that way. So I'm just going to put it on channel 20, which we're on. We key up, and hopefully I can see, yeah, very obvious where the peak is. Both of those were a bit out. So then we want L14 and then 13, 12 and 10. I'm doing this right. 14, that's peaked. That's peaked. I think Mr. Chippy mentioned some of the coils were stretched in this and he unstretched them yesterday. Which is probably why we've got a different power reading. That didn't work out. I'll just go back on that one. Yeah, that's peak. There we go, full 4 watts. I'm interested on, this isn't one of the official tests, but I'm just interested how it tracks on the other channels. Channel 40, 3.6 watts. Channel 1, 4.1 watts. I'm tempted to alter this. It doesn't tell you to do this, but I am tempted to. I don't know whether that's going to improve the balance. Let's see where we are now. So it's about 4.05 watts on channel 20. It's 4.1 on channel 1. About 3.7 on channel 40. It's a bit better balanced. Okay, so we've done that. Now we're going to go for the low power setting, which should be 0.4 of a watt. Let's see what that is now. It's now 100 milliwatts. It was 50 milliwatts before, so at least that's altered a little bit. Low power is that adjustment. It's dirty. Let's see if it's undirty. That's 400 milliwatts. We'll go back to full power. 4 watts. Good. So we need to make sure that the meter is on the between the green and the red in the transmit meter. Oh, I can't see the meter moving at all. We never checked that yesterday, did we? So second. Oh, we're in a situation where the meter doesn't work on this. You know, this is frustrating. Let's see whether there's actually power coming up to that meter. Yeah, it's getting a signal all right, but it's not doing anything. Well, it looks like we'll have to skip that stage. Let's have a look at deviation. Okay, get the little oscillator out. Bring up the deviation. Wow, that's a little bit high. Wow, that's spot on. So what are new meters? 27 quid. Order them from Italy. Alright, we'll move on to the receiver. So let's see where we are on the transmit frequency first, and I'll set the receiver accordingly. 27,78944. Okay. So just explain why we're doing this. Remember, this radio, the synthesizer generates all the frequencies from one reference crystal, which is 10.24. That reference crystal's clearly dropped out of spec, but I'll do some maths to make sure it really is out of spec. So if I tune this to the correct channel, 27,79125, if and when we fix that problem, then the receiver would be lopsided. So we need to set the receiver at the frequency being presented, which is that. Okay, so we'll start off by looking at the detector. I don't know what they tell you to do first. 1, 2, 3, 4. They tell you to do it 7th step. Well, there you go. They've had different training to me. So put the oscilloscope there. Put an S9 equivalent signal on of 100 microvolts. Adjust the volume to a meaningful level. And adjust the detector, which I think is that one. I'll just check. Yeah, it is L19. Very slight improvement there. Any improvement's worthwhile. So go back to, or go on to the synod meter, and we need to drop that to about 4 dB so that it's not saturating the receiver. Drop the volume a little bit, and they want you to do L6, 5, 4, 3, 2, 1 in that order. I don't think that's the right way. It isn't the right way around. I think that's a flawed decision. So we'll do it the other way around. That's an improvement. The earthing the radio is affecting the reading, so I'm going to hold on to it. Put a bigger signal on for that. And that. I can't see that. Let's go for a low signal. Can't see that. Let's go for an even bigger signal. Seems to be there. Yeah. So why aren't I getting an earth properly? Just do an experiment. Put that clip to the test set. No, I mean that's fixed it. So why isn't it picking up an earth through the aerial socket? How bizarre. I'll be checking continuity of the aerial plug in a bit. So, our new reading for 12 dB. I need to put the bottom lid on this, and I have to get that off Chippy's bench. Let's check continuity. Okay, so what I've done, do you remember that Midland 2001 which I was given by... Well, if I pinch a reference crystal out of it and put it in this set, because I was given it, I can pass that gift on, can't I? And it'll save spending a £5 on a new one. Let's make sure we're off. We are off. Actually, that could be doing with being better. Got to be quick soldering crystals, or you destroy them. So we'll put the bottom lid on. Look at the corrosion on the side there. See what it's doing now. So we're back to transmit. Test set's been on long enough now to get a meaningful reading. 2779157, so it's slightly high. It's not adjustable. That's fixed that problem. One of the legs fell off the original crystal as I took it out, and it's just corroded. It's had water ingress in this set at some point. So that's fixed that problem. We're still doing 4 watts, actually 4.1. So let's see whether we've just run through this receiver again with it reset for 2779130 this time. We'll put 2779. I think this was so far off frequency people would have been struggling hearing him. I think we'll put it there. That's about right. We'll just run through this receiver with the lid. This is where we're going to adjust this one again. If you remember, we set it with the oscilloscope early on. This is the amount of injection into the IF. Don't think those other two will have altered, but I will just check. I think that's about right. But have we got any improvement? Right, well, the answer is yes. So for 12 dB, we've now got 1 microvolt, which is about what you'd expect on this chassis. So we'll start with that one. We've now got 1 microvolt. So if you remember, the manual says the limit spec is 1 microvolt for 10 dB. So what's the 10 dB now? About there. It's 0.82. And for 20, let's hope the radio will still achieve 20 at some point. It will. It's now 2.8. Now you'd expect that with all the change of capacitors to higher quality ones, that one would actually be better, but it isn't. But it is, obviously, it's now exceeding specification rather than before it was just meeting specification. Good. So that doesn't, of course, fix the meter. I mean, this is like taking your car for a service, isn't it? And in actually, the speedometer doesn't work, but you don't tell the garage that the speedometer doesn't work, and the garage decides to strip it down and see if they can do anything with it. I'm actually waiting for some parcels to arrive, and so, to be honest, I can't really do much else. So in view of that, we'll take it apart. Okay, so we'll open it up. They're usually sellotaped for overseas viewers. I've no doubt there's other brands of adhesive tapes. My late mother said that before the World War II, in the 1930s when she worked at the hospital in Sheffield, the leading brand was Durex. I think if you asked for a roll of Durex today, it would mean something else. I hope this one isn't glued together. I need to open it up with something. Oh, you have to be so careful with these. So, is the needle actually stuck? Yes. So I can put that absolutely anywhere. So what we need to do is, I think the bearings have got too tight, probably through corrosion. I'm looking at it, it's probably that top one. So is that a precision screwdriver? Yes, it is. not precision enough. I'll just go and open up the, was it Aldi or Lidl we got a precision toolkit from the other week? Right, so I've got the smallest precision screwdriver we've got, which wasn't in the Lidl kit. I can't turn that one, so see if we can turn the top one. We have freedom. So without now powering it back up, we now have deflection on the meter. All we now have to do is try and put it back together. And to get the scotch tape from Mr. Chippy's workshop. So having put it back together, I've just done the isopropyl alcohol on the back of the printed circuit board, and hopefully that's an improvement as well. So we'll have enough confidence to put the bottom on. If I can find a screw amongst those duff capacitors. One of the ones in the audio circuit did read no component detected on the tester, so that wouldn't have helped at all. So I've asked the customer if he's got a proper standard mic rather than that Altai Echo power mic that he sent. I'm not really happy about wiring an Echo mic. It's something I'm dead against, and it's actually a legal grey area. So it's a difficult one, isn't it? Right, so we've now got two more adjustments to do for the meter. Helps if we power the set back up. Oh, we ought to test it on PA, oughtn't we? Like doing that. Testing 1 2. Hello, testing 1 2 1 2. I'm turning the squelch. Testing 1 2, testing 1 2. Testing 1 2, testing 1 2. 1 2. This is one of those sets where you can't adjust the volume of the PA. Now you see, this is why we're testing these things, because when you're doing something like a great GT868 and you find that on a set which is relatively cheap, you kind of half expect that, but you don't expect it on this. So that's disappointing. Right, back to CB. So we'll backtrack onto transmit, and we want the meter to read, still doing 4 watts. In fact, we'll take picture in picture off now. So we want to have that somewhere around where they say, which funnily enough is about there. I'll just change glasses. So the RF meter is RT3. I've dropped out of this thing. They actually want it to be on the dot between green and red, but halfway across the red seems to be a more sensible place to put it. And as I've said a million times before, remember when you've got this on an aerial, because we're on a dummy load in the test equipment, when you key up, it may only just move and it may swing across. It doesn't mean you're doing more or less power. You're still doing 4 watts if that's what the radio's doing, which it is in this case. It's relative to SWR and all kinds of things. So that's that setup. Now we want to put an S9 equivalent signal on the test set, which is now there, and I need to adjust the meter so that reads S9. It needs to pop up a bit. So which one is that without me looking at the service manual? It is SM signal meter. So there we are on the 9. And then finally we'll do the squelch. So I'll put picture in picture back on, and we'll look at the attenuator controls. And so at the moment we're at 100 microvolts. I'm just going to drop that off. We'll set the squelch to full on the radio. I did put some service salt switch cleaner on those, and they're working now. So with squelch on full, I want the squelch to open when we get to 100 microvolts, which is S9. So 1 microvolt, 3, 10, 30 microvolts, 100. So that needs adjusting. So the squelch preset is the one that says SQ. Now is it like that? It won't open at 100. Let's go up a few pegs till it does open. So that is maximum sensitivity. And it's 600 microvolts to open. So at least it does open at some point. It's not ideal. So then we'll drop down to the opposite end, and I'm going to park the signal generator and put it to standby at 0.3 of a microvolt. Now we'll adjust the squelch and then set threshold. Yep. Now we'll put the signal generator back on. Oh, that's nice. It's coming in at 0.65 of a microvolt, and it's leaving at 0.55. They're a bit better than the cybernetics with squelch, but they're much less sensitive sets, which is probably why they were better for bleed over, because they were less sensitive. Yeah, that's absolutely fine. And out of interest, we know what we've got on the Synad meter. We've already taken those readings, but I'm just wondering how far we can actually hear it down to. So at the moment we're listening to, I'll just turn the squelch off, otherwise it's going to come in. So that's 1 microvolt, that's 0.3. So to hear down to about 0.25 of a microvolt. Right, so there we are, we're all done. And it's actually worked out better than I thought, because I thought, well, this is quite a tired set. So I'll just go and retrieve the speaker lid from Mr. Chippy's bench, and we'll wrap that job up. Time to put the speaker back on. Although it doesn't matter which is positive and negative, it'd be interesting to find out, because in their infinite wisdom, Uniden have used 2 grey wires. Seeing as it's a negative earth, which one of these goes there? Not that one. That's the earth. So that is the lower one of the 2. The one towards the back is the earth. Now, Mr. Chippy took this speaker off and he said the solder was pretty poor, so we'll just re-tin this. Earth towards the back. Notice there's 16 ohm speakers in these radios, and they're square ones, so you don't want to be losing the speaker. You're not going to get another. Now, because echo microphones are grey area, I'm not prepared to wire the echo mic supplied for the customer. It was his late father's, and yes, fantastic to keep that kind of thing, but I've been told specifically not to be involved with echo mics. Oops. If they were any good, then the military would be using them, and space would be using them, and the police would be using them. They're specifically outlawed on amateur radio, so it's a very grey area on UK CB radio. In fact, all power microphones are a grey area. The only time the Ofcom have said to me they will kind of turn a blind eye to it is when it's a stand microphone on a base station and the person has a disability. This isn't like AM, you know, in the American days where talk power is king. All the UK radios are speech processed. So you don't want to be using... I remember those £6.99 power mics with the single AA battery in them. And this was at a time when replacement microphones were about £7.50, ordinary replacement microphones. And you think, well, if the power mic £6.99 and the proper replacement mic £7.50, there's got to be a quality difference, hasn't there? Well, of course there is. Right, that's that back together. We'll hope the speaker works. Done is I've found a coffin mic amongst our bin of unwanted mics, and I've wired this for him, and I'm going to give him this as a free gift. It's branded TriStar. There are no TriStar radios in the UK that are legal, and so this can just be... It was probably given to me, so I'll pass again that gift on. There we go. One on a Roger. You'll be lucky. Quarter to 5 on a Friday. 19 a Roger. Okay, so that's that. We'll leave it there, and we'll do an on-the-air test later on with Mr. Chippy. So there we have it, the Uniden Uniace 100. Now back in land of the living. Thanks for watching.